Uh, Good morning, everyone. Today we'll be performing moisture analysis. Moisture content is simply how much water. Moisture content means how much water is present in any product that we are going to analyze. Moisture content affects a lot of the aspects of the product, such as processability, shelf life, usability, and the quality of the product. That's why accurate moisture content determination is very important in the industries like food industries, pharmaceutical industries, and chemicals. The identification and efficient operation of reliable moisture analysis equipment is an essential component of any laboratory or production environment. There are different kinds of forms in which moisture can be present with any product. These are free water, absorbed water, or water of hydration. If the water is present on the surface of the test substance, it retains its physical form, and that is called free water. If the water is present in the large pores or cavities, then it is called absorbed water. And if that water is occluded in lattice ions or the water of crystallization, it is called water of hydration. There are different types of moisture measurement depending on the requirement. These are drying method, Karl-Fisher method, dielectric method, infrared absorption method, and neutron analyzer. But today we'll be looking at drying methods. Drying methods can be of two types. The first is oven drying method, and the second is halogen moisture analyzer. First of all, look at what is oven drying method. In this method, a sample is dried for a particular period of time at a constant temperature, and the moisture content is determined by weighing the sample before and after drying and determining the difference between the two. There is a formula given here which is used for calculating the moisture content of a sample. Here, small w is equal to wet weight and d is the weight after drying. That is, w is the initial weight and d is the weight after the drying process. And this formula is then used for calculating the overall moisture content of the product. Another is moisture analyzer. It is a laboratory instrument designed for precise determination of moisture content in the sample. It provides accurate and quick measurements, making it a valuable tool in quality control. In moisture analyzers, either halogen heating or infrared radiation is used for heating the sample, and this causes the moisture to evaporate. It works on the principle of thermogravimetric principle, which determines weight loss upon drying. It occurs in three steps. First of all, the sample weight is measured and the heat is applied to it until all the moisture is driven off. At the end, the sample is weighed again, and then the difference between these two is calculated to determine the moisture content. The weight loss at the end of the experiment is recorded, and it is the moisture content of the sample. Here you can see the diagrams of the moisture analyzer. Here we can see the basic difference between drying oven and the moisture analyzer. In drying oven, is tra- heating is provided through the process of convection, and in moisture analyzer, halogen heating or infrared radiation is used. In drying oven, broad range of temperature is used, but in moisture analyzer, uh, precise temperature can be employed for the process. In drying oven, drying oven is suitable for large samples, but moisture analyzer is only used for smaller weight samples. Oven drying is a comparatively slow process, whereas moisture analyzer is a rapid process. It is used for general applications in drying oven, but In moisture analyzer, it is used for it is only dedicated for determining the moisture content. Drying oven is usually used in industrial processes, and moisture analyzer used in laboratory settings and quality control. These are the few applications of moisture analyzer. It is used in food industries, pharmaceutical industries, chemical industries, and also in environmental industries. This is the moisture analyzer. First of all, we will be checking whether the instrument is balanced or not. So for ensuring that, we will check whether that this circular ring is in the middle of the circle or not. It's already in the middle, but if it is not, then we'll be adjusting these screws given at at the bottom of the instrument to bring that ring in the middle of that circle. There are four options given here: print, menu, tear and start. We can print our result, but for that will have to connect this instrument with the printer. Then there is menu. If we'll go into this, we'll have several options. There is one option for calibration. The machine is already calibrated. There is an option for printer, history, settings, language, system settings and the system. Now we'll look at what's there in the settings. Then there are four options given here: testing mode, temperature settings, stop mode and the time setting. If we have to perform our experiment for a particular period of time, then we can set the procedure to that time. At this time, the instrument is set for 3 minutes. Then there is stop mode. In this, we have three options: auto stop, timing stop and manual stop. If we select auto stop, then the machine automatically stops after the process is completed. Currently, we have chosen timing stop, and there is manual stop. It means we can stop the process whenever we want. But we have to perform this experiment for 3 minutes. That's why we have chosen timing stop. Then there's temperature setting. For this instrument, the temperature range is 40 degrees Celsius to 190 degrees Celsius. We have set the instrument to on 190 degrees Celsius. Then there's testing mode. There are three options: standard, fast and soft. We are keeping it on standard mode. After that, we'll be tearing the machine. It's already on 0 grams weight. If we look at the instrumentation of this machine, there is a halogen light. It provides heating. Then there is this platform on which we can put our sample. The weight range for this instrument is from 1 grams to 110 grams. It means we have to at least keep 1 gram sample for the analysis. So the sample that we are using now is whole wheat bread. First tear it. Yeah, now it's tear. It's more than 1 gram, so now we can start the experiment. We'll close this now and then press start. You can see the temperature is now gradually increasing. It will increase up to 190 degrees Celsius, and after that there will be no further increase in the temperature because that's the maximum temperature for this instrument, and we have also set it on 190 degrees Celsius. The timing that we chose is 3 minutes, so the process will carry on for 3 minutes. The instrument will automatically calculate the moisture content, and at last we'll be getting the final weight and the final moisture content that it detected in 3 minutes.
So after 3 minutes, as you can see, after 3 minutes the process automatically stopped, and this is the moisture content that it calculated in the duration of 3 minutes, and this is the final weight. Thank you.